In this video, I'm going to discuss the area under the curve. Now, if y is equals to f of x is a positive and a continuous function, what I mean here is this function here is positive and continuous on the interval AB. So from x is equals to a to x is equals to b, the area a bounded by y is equals to f of x. So this area here um, will be given by the definite integral of f of x from x is equals to a to x is equals to b. So the area will be given by this definite integral. Okay, so that's the most important thing. It has to be continuous and it has to be positive, and then you just find the definite integral of that function between those two limits. Now, I'm going to explain this in this question here. It's just an example that we can use to understand the process. So, the function that you're given here is y is equal to x cubed. So again, let me just get this. So y is equals to x cubed from x is equals to 0 to x is equals to 2 and the x-axis. Now, what I'm going to do is to sketch this so that you can have an idea of what's going on. So basically what we have is a cubic function. Now this cubic function may look something like that. Let's not try again. Yep, something like this. So y is equals to x cubed. I'm just sketching so that you can visualize what's going on. Now this is from x is equal to 0 to x is equals to 2. So somewhere here, x is equals to 2. And what you're trying to find is this area here. Okay, this is area A, what you're trying to find. Now, we said that area A will just be the definite integral of this function, which is x cubed, from x is equals to 0 to 2, and we are differentiating with respect to x. So this will be equal to x to power 4 over 4, and the limits are 2, 0. This will give us 2 to the power 4 over 4 minus 0. Remember, I'm just plugging in the limits. So you'll end up with 4. Okay. You can also check this on your graphing calculator. So if you grab your graphing calculator, I'll show you how to work out this process. Just go to alpha, the same way we found definite integrals. And then you go on to number 4. The lower limit is 0, the upper limit is 2, and then you have your function x cubed, and we're integrating with respect to x. Okay, and you'll end up with the same answer as what we have here. There's also another way on how you can do this. So using a graphing calculator, go on to y is equals to, plug in the function x cubed, and then just graph it. So you have the function. Now what I'm going to do is zoom box, Z box, just to highlight the part that I want. So from x is equals to 0 to 2, somewhere there. Okay, have a better view of the graph. And then what I want to do is to show you another method. So second graph, no, sorry, not that one. Second, calculate, and then go to number 7. Now, What the calculator will ask you is the lower limit, which is 0. Just plug in 0. The upper limit is 2. And then you'll get your similar solution, and the answer is 4. From here, you can see that same answer as what we got. So those are two ways on how you can use your calculator to find the area under the curve. Okay, good. The next thing that I want to look at is negative areas. Now, of course, you can know that functions can be negative and they can be positive. And what you're saying here is, just pick a highlight again. So if y is equals to f of x is negative, okay, so if y is equals to f of x is negative over the interval ab, so you can see that this function here is negative from x is equals to a to x is equals to b. You know that the definite integral will be negative, so this will be a negative answer. And to find the area, we'll find the definite integral of that function, but now we'll add a minus to it, because we cannot have negative areas. So it makes sense to add a negative to end up with a positive area. Good. Sometimes you can also have areas straddling on the x-axis. So for example, here we have this area, this function being positive above the x-axis and then negative below the x-axis. But we want to find the area of these two parts. We want to find the area of A and the area of B. What you can do is you can find the areas of these two separately. So find the area of A separately. Of course, that will be a positive answer. Find the area of B separately. It will be a negative answer. But because you want it to be a positive, you add a negative to it, just like we did in negative areas. So you add a negative there so that you end up with the area of B being positive. And then you just add them up. Alternatively, you can find the absolute value of that. Okay, so absolute value of that plus the area of, the positive part of the function, and then you just add them up. Okay, so this is an alternative method that you can use. Good. Now, just summarizing all the things that we've been talking about. The steps of finding areas. One is to sketch the graph. Okay, so sketch the graph, very important. Then you integrate, and then you add the areas. Okay, you sketch, integrate, and then add the two areas. If it's just one area, then sketch, integrate, and then you have your area. And now look at this example here. Find the area of the region bounded by the graph y is equals to a half x minus 1, x plus 2, and x minus 3. Now, the first step is we need to sketch this function. So let's just try and sketch. So what are the things that we need to know before we sketch this function? We need to know the zeros of this function. So we can say at y is equals to 0, or we can just say the x-intercepts. So x-intercepts are so we have x is equals to 1, x is equals to negative 2, and x is equals to 3. Okay, we also may be interested in finding the y-intercept. So the y-intercept so the y-intercept here will be at, we can find it at x is equals to 0, y will be equal to a half multiplied by negative 1 multiplied by 2 multiplied by negative 3. Now, if you work that out, that should be able to give you 3. So we can now try and sketch this function. Remember, this is just a sketch. Does not mean that it has to be exactly the way it is. So negative 2 is somewhere here. 1 will be somewhere there. And then 3 will be somewhere there. Okay. So our function, the leading coefficient is positive. It's a cubic function. So which means we'll end up with something like that. Okay, something like that. Not exactly, but something like that. Okay, the y-intercept is 3. So somewhere there, 3. Now, what you want is to find the area of the region bounded by the graph of the function, the x and the x-axis. So the area that you're interested is that bit there and that bit there. Good. So what I'm going to do to make my work easier, I'll just label this A and then I'll label this B. I'll work out the areas of the two graphs separately, two parts separately, and then add them up together. So the first thing to do is, before we actually start integrating this function, we need to simplify it, because in this form it will be difficult to integrate it. So we need to FOIL this, and that will be my first step. So just extend some space here. So the function is y is equal to a half into x minus 1, x plus 2, and x minus 3. So to FOIL it, I can start with this bracket, pair of brackets. So y will be equal to a half into x minus 1. This will give me x squared minus 3x plus 2x minus 6, which will give me a half into x minus 1, x squared minus x minus 6. Okay, the next thing will be to expand these two brackets. So a half into x cubed minus x squared minus 6x minus x squared plus x plus 6, which will give me, if I simplify that, x cubed minus 2x squared minus 5x plus 6. So just putting this together, I end up with y is equal to a half x cubed minus x squared minus 5 over 2 x plus 3. Now this is the function that I will be integrating. Okay, the first thing that I'll do is I'll start by finding the area of A. So area of A. So area of A will be, now the limits for A is negative 2 to 1. Then you have the function minus x squared minus 5 over 2x plus 3. Now, if I integrate that, I will end up with, I'm not sure if it will fit here. So that will be a half x to the power 4 over 4 minus x cubed over 3 minus 5 over 2 x squared over 2 plus 3x, and the limits are from -2 to 1. This can be simplified to x to the power 4 over 8 minus x cubed over 3 minus 5x to the power 2 over 4 plus 3x with same limits. So -2 to 1, which means if I plug in 1, I'll end up with an eighth minus a third minus 5 over 4 plus 3. And then if I plug in -2, I'll end up with 16 over 8 minus and minus will give me a plus. So just will be plus 8 over 3 minus 20 over 4 minus 6. So this will be, just write it here below. This will be 37 over 24 minus -19 over 3, which will give me 63 over 8. So the area of A is 63 over 8. I can go ahead and work out, so that's the area of A. I can go ahead and work out the area of B. So area of B. Now, in part B, I know that from the graph, just going way up to check the graph, you can see that part B will have a negative area. So keep that in mind. We'll have to find the absolute value of that or multiply that by a negative to end up with a positive answer. Anyway, let's carry on. So the area of B will be, you can just say negative into bracket, because we have the same integral function, so we'll basically have the same answer when you integrate. So instead of doing it again, I'll just copy the answer that I had, and the limits are from 1 to 3. Now note here that I've added this negative here because we know that because the function is below the x-axis, it will be negative, and we want to end up with a positive answer. That's why I have the negative there. All right, so what we'll end up with is negative. Plugging in 3, I'll have 81 over 8 minus 27 over 3 minus 40, that will be 45 over 4 plus 9 minus an eighth minus a third minus 5 over 4 plus 3. Good. So which will give us negative 9 over 8 minus 37 over 24, which will give us negative 8 over 3, which will be 8 over 3. Okay, so that's the area of B. Now what we want is the total area. So the total area, which means A plus B, will be 63 over 8, 63 over 8 plus 8 over 3, which gives us 253 over 24, and that will be our final answer. You can plug this in your calculator. Should be able to get 10.5. But that's the process. That's the process on how you can work out the area of A and B. That straddle about the x-axis. Anyway, something else that I wanted to show you is how you can use your calculator to work out this area. Now, to work out the area of this particular function, I'll just go up again all the way. The first thing that you need to do is to use the same process the way we did definite integrals. Then select 4. But then what I'm going to do is, instead of plugging in the function here, I'll plug in the absolute value of that function. Okay, so the lower limit is, of the 3 limits that we have, -2, 1, and 3, the lowest is -2. So I'll put in the lowest, -2. The highest is 3. Remember, I'm skipping the middle one. And then here, I won't just plug in the function, but I'll plug in the absolute value of that function. So you go to math, absolute. And then I'll plug in the function. You can plug in the way it is, 0.5 into x minus 1 multiplied by x plus 2 multiplied by x minus 3. And we are integrating with respect to x. Don't forget that. Now, if you press enter, takes a while, we end up with the same answer, 10.5.